Vice Nation Academy 2026 inaugural booth crawl. So excited to be here at Oxford Performance Laboratories. Scott DeFelice, Vincent DeFelice, talking about some super cool stuff. Welcome to New Orleans, guys.
Kevin, thanks, man.
What an exciting time to be right here, right now. The first time I ever saw this material on social media, I was just pulled. It was like a bug light, right? I just got pulled in, and your mind starts spinning what all you can do with it. Walk us through what it is, what you're doing with it, and where Oxford is now.
Yeah, so OPM started as a material science company working in this one really cool polymer called PEKK. It's a high-performance thermoplastic, and we've been in orthopedics for a long time. We started about 15 years ago making custom cranial implants, and Zimmer Biomet is our distributor for that product. We moved into spine and some other indications, but then we saw the personalized implant market really starting to pick up and others going into space, and we said, hey, we got a better mousetrap here. So our product is called OsteoFab. It's 3D printed PEKK, and it's actually a very unique biomaterial. First of all, it's mechanically like bone, which we all know the benefits of having a material that's mechanically like bone. It's osteoconductive. Bone loves to grow on this stuff. It's amazing. It's bacteriostatic, so infection, we all know that's a huge problem. It's radiolucent, so the benefits of that are really clinically clear. And it's modifiable in the OR, and that's something we didn't think was going to be a big thing, but then surgeons were like, we love to have a bailout. We love to have an option where if my planning isn't perfect, we're going to get an implant that really is something I could work with. So we've been started out mostly in lower extremity to start when we moved into the personalized space, doing things like these polished total taluses, arthrodesis, implants, and now we're starting to move into other spaces. We're doing these triflanges, intercalaries, lots of different, anywhere where you have a large segmental defect, we have a solution. We like you to think of us as, hey, I'm in a corner, I need a solution, I have a compromised patient, I have a difficult case, where am I going to go? We want you to think of Oxford Performance Materials.
Wow. What a great point about that. So many of these constructs in our space are metal, and I never really thought about, you can't really take a bird of that elegantly and start doing some fine tuning, right?
Yeah, there's a lot of flexibility in the system.
Let's talk about flexibility. You said it's like bone, so the modulus of elasticity is...
Yeah, it's right at cortical bone. I'd like to say we designed and developed this polymer for this purpose, to be like cortical bone. We got lucky on that one, right? We were developing this with NASA and Boeing for manned spacecraft. That's actually one of the earlier use cases. But it turns out to have this really biomimetic property, both mechanically and biologically.
So one thing that we talked about earlier, I just want to touch on because it just blew my mind. You can actually do PEKK on PEKK.
Yeah, so we're starting to research PEKK on PEKK as a wear couple.
Right.
PEKK is a really unique unique wear properties in that it actually pulls down lubricant onto the surface. So the proteins in the body are attracted to this material. That's why the bone grows on it. That's why it's bacteriostatic. So it's got very good wear properties inherently, and then in the body, it is even improved by the biologic response.
What do you think?
Biofilm doesn't grow on it, does it?
No, so that's the same mechanism of action. There's been a number of papers now that have been published, one just recently, exploring that mechanism of action, and it's a surface energy thing, right? So all materials have specific surface energies, and this particular material just happens to have the surface energy of the endogenous proteins. And they get attracted to the surface, it results in a natural healing cascade, and so you don't get the biofilm, and then you get the apposition, and then you're off to the races.
So let's pretend here for a second. Dr. Shields has a DFR he's looking at doing. What does that process look like in terms of getting the plans to y'all? How long does it take? Or anything that he would want to make for that exam.
Okay, I'm going to kick that over to Vince. That's his game.
So what's nice about the process, it's if you've done custom implants in other materials, probably metal, it'll be a very, very familiar process. So it starts off with a high quality CT scan, 1 to 1.25 millimeter slices, a prescription form so we understand sort of the condition of the patient so that we can prep the scan and prep some initial models. About a week after, we have a design meeting with our engineers to go over some some of the preliminary designs, make some modifications, talk about fixation, sort of the approach of the fixation, any maybe models or cut guides that might be required to create the resection, especially if we're talking about maybe there's a tumor involved that has to be resected with appropriate margins. After that, we sent out a proposal with the sort of what was discussed on the design meeting. And then if that looks good, you sign the bottom line, and basically about 3 to 4 weeks later, we ship the implant. So end to end, from scan to shipment, it's about a 6-week process is typical.
Okay.
Yeah.
What can Brown do for you? I think that marketing slogan was taken.
I was about to say UPS, we use FedEx.
Yeah, I don't know about y'all, but when I see this table, my imagination starts, what about this? What about that? I mean, is there anything you couldn't do with it, right? It's really an inspiring technology.
Yes, one of the things that I found most fascinating about this business, well, my background's not from orthopedics, right? I come from material science, aerospace, and so I'm always coming at this industry with somewhat of a naive lens. Like, really, you're using metal for all this stuff? Oh my God, I don't know, why are you doing that? Well, it's the only thing you had. I get it now. But one of the things I find fascinating is when I get with clinicians, and they start talking and thinking and seeing the wheels turn about potential solutions. And so all these solutions now are really driven on this direction of personalized, on-demand, metal-free orthopedics. Like, one of the business innovations of this technology, we've talked a lot about the innovations in terms of the material science and the clinical aspects, but the business innovation is really interesting to me as well, which is that you don't have inventory. You have an implant in a box, right? So what's the experience like now? And we're doing some TAR cases, and it's just an implant in a box for a total ankle. And the surgeons basically say, we love walking in, not having all these trays, not having all this stuff, not managing all this complexity, opening up a box. What's in that box is made for my patient. I know it's going to work, it's plug and play. And so that's the business innovation, and we want to drive this industry towards metal-free orthopedics on demand, simplify the industry, make the implants for the patients. And yeah, we're starting on the edge, but we're not going to end on the edge. We're going to continue to move and develop into areas that are occupied by the people with the very big booths here. But right now, we're in a very small booth.
The operating room is pretty modifiable, I would assume. I can burr it down, I can drill holes, and
yeah, so you can do all that, and that's a huge benefit if you get into these complex cases.
It's kind of like just drilling through cortical bone is what it feels
Well,
like.
you could talk about that a little bit.
Yeah, so it's like drilling through cortical bone, except it's kind of old cortical bone. So you do a little bit larger of an underdrill relative to the diameter of the screw hole, and the screw will bite in really nicely. We have really rigid fixation to the implant.
I noticed this surface treatment is sort of unique. Have you worked with different kinds of surface topographies to see what the bone likes?
Yeah. So that's a subject we've studied a lot. So first, the bulk material, the bone likes that bulk material, and there'll be apposition to that bulk material.
Just to a smooth surface.
To that surface as well. All that bulk material. This material really wets well, so anything in the body, any fluids are going to suck in completely intimately to the implant. But this structure here is designed for really two reasons. Why do we like that structure? It imparts a really good mechanical profile. It creates opportunity for substantial bone ingrowth that is mechanically meaningful. And also from a manufacturing perspective, we can manufacture efficiently and remove all the powders. So it's a highly designed topography.
And it makes it lighter too.
Sure. So it absolutely does. It is part of the light weighting.
Inherently, PEKK is about 1/3 the weight of titanium, about 1/7 the weight of cobalt chrome. And so if you think about like a talus, it's actually, a PEKK talus is around the actual weight of what would be a natural talus.
Very interesting.
So that ankle in the box you're talking about, it's PEKK on PEKK implants?
Why don't you talk a little bit
So
about those?
right now we're using PEKK with a mobile bearing poly in between.
Gotcha.
So a standard sort of off-the-shelf poly that's available on the market.
Wow. It's a docs and reps booth crawl, Joseph. What do you think? Is coming from the industry side, would something like this be exciting to have in your bag?
I think it is. It's very advanced.
Yeah.
So I think this is a real specialty. I'm intrigued by the advancements you were talking about as far as how far you're going to go with this. I think that would bring a whole different interest level to me.
Yeah, let me sort of address that. So, right now a lot of what we're doing is customs pathway, except our cranial facial implants are all 510K, but we do have projects now where we're going to move towards 510K and go to personalized. So we have a tri-flange project that's it's well on its way. That will be a product that will be coming out, so that'll be a cleared product. We are exploring a total ankle. I know you're going to look at me and be like, no way, dude, you're not doing a total ankle. That's going to be too much. But we believe the technology is right for it. We've done quite a number of cases. The results are great. So we're going to try to figure that out, figure if we can move into that space. So yeah, we're gonna extend this into indications that I think are really meaningful.
This technology is very meaningful. What you can do with it is meaningful. And it's just incredible what y'all put together with this material and what you've been able to build out from that. It's just jaw-dropping. Wish you guys great success. Really appreciate you allowing us into your booth to talk about it. For people that are watching this right now, Scott, that are like, surgeons going, I'd like to look at this for a patient, or just to add to my armamentarium, or maybe even a potential rep out there that might want to think about adding it to their bag, if that worked out for y'all. How do they connect with y'all?
Yeah, the best way, reach out to me on LinkedIn. That's the best way. Just connect, say, hey, I have an idea, I have a thing, I'd like to talk, I'd like to learn more. We'll get that discussion going right away. We'd love to have those.
Orthopedic community is kind of coalescing around LinkedIn, aren't they?
Yeah, I think it's a great place to meet and engage. To me, it's like you have to have your presence out there and be talking about real things, not be talking about yourself.
And your cat.
Yeah, and your cat. Talk about your technology, what you've got to offer, how you're going to change the industry. I think people are attracted to that type of thing.
Well, we can't wait to share this content on LinkedIn with the Device Nation community and basically the world. Super excited. Again, thank y'all so much and wish you guys great success.
Hey, thanks, Kevin.